Okay, in this video, what we'll do is we'll go through and use the API in Amber to run a collection of vehicles on a collection of cycles. So what we'll do in this case is we'll start with a new script here. And what we want to use is we want to use the run vehicles. Run multiple vehicles class. So there's this PXF run multiple vehicles. And there's a static factory method to create it. So we use this method to instantiate it with all of its defaults. We'll do create run using defaults. So that will set it up with all the default values. And what we want to do, let's create, we'll need to create a list of vehicles. So if we do a vehicle list here, what I'll do is instead of typing it out, I'll just get a list and copy these in. So we'll run a conventional mid-size spark ignition 5-speed automatic vehicle. Then we'll also run a BISG mid-size SI 6-speed. So that's belt integrated starter generator. So this is a mild hybrid vehicle. And then I will add a pre-transmission hybrid vehicle. So this is a parallel pre-transmission. So the motor is just before the transmission and it has an automatic. And then I'll also add a power split vehicle here. Put the semicolon. So that's our vehicle list. What we can also do is let's create a list of processes. So we're running these vehicles and we want to run them on a group of processes. So we call them processes just because some might be simple cycles and others might be procedures. So to kind of group it together, others might be a little bit more complicated. It could be an optimization. So what I'll do is I'll add in some cycles. So I'll add in a city cycle. So that's FUDS1. So that's a standard city cycle. And then I will add in a highway cycle. And then I will add in a USO6. So these are from the 5-cycle procedure. And then we'll add in one of the processes. So we'll add in a acceleration process. So to see what the 0 to 60 time for this vehicle is. These are all under the Autonomy Common repository. So if you go to Autonomy, you go to Cycle, you go to Vehicle. You can see all the vehicles or all the cycles that are selectable here. So what I'm putting in is just these cycle file names. So there's various ones that can be selected here. You can see the full list. So they're all in the Autonomy Common folder. Vehicles are in the Autonomy library here, Autonomy Energy Library, Systems, Vehicle, Systems, Light Duty, and then you could find, the different vehicles here. If once you've set the path, you can also do PXF library browser and then just list vehicles if you want to just get a quick list of the vehicles that are available. So those are all the vehicles that are under the Amber Autonomy Energy repository. So that's really what I'm going through and using here. So, okay, we have a list of vehicles, we have a list of processes. And then what we can do next is let's loop through the vehicles and loop through the processes. So we'll go through for j equals 1 to the length of the vehicle list. And then we'll go for I equal 1 to the length of the process list. And then what we want to do in here is we want to create what we call here a single run. So this is a set of multiple runs, but what we want to do here is we want to create a single run. So we'll do run multiple single runs. So it's just to indicate that this is the run that's being used by the multiple vehicles class. And what we'll do is we'll do the vehicle list. And then we'll just do the process list. Now, this example will just show how to combine the vehicle and the process one-to-one, so or all combinations. But you can do other things here too. You can change parameters in the vehicle. You could change files in the vehicle. You could go through those later. So now what we'll do is we'll just do run vehicles, and then we'll do add run. So you have to add the run to the vehicle. So add run vehicles process and then single run. That's right. And then what we can do then is just at the end, once you add each one of these single runs, so you instantiate a single run, you add it to the run multiple vehicles, and then at the end what you want to do is you want to do a run vehicles.run. So it has this run method, you call the run method, and it goes through and it executes those simulations. Now what we can do at the end is we could do run vehicles and we could get the results table as a vect table. This is just an Amber table that has some methods to be able to do lookups on columns in the table based on keys. So we could save this out. I will save it to this folder. We'll save it to the runs. So we'll just call this save as demo 2 pxf run multiple vehicles. This itself is in a folder. So if you go to development and you go to the program folders and you go to batch runs here, this is actually, I think, example 3. So you can always find the full example in that batch folder. So if you want to know where that is in the release, you could go to program folders, example batch runs here, and so this is whatever release version you're using, your release. So I'm using an internal development version. If you're using the 2024, then it would be 2024. If you're using the 2025, it would be the 2025. So whatever version you're using, that's the one that appears there. Okay, so what we have is pretty good start. So this is enough to get it running. So what I'll do is I'll run this and then we'll just come back and look to see what it creates. So now that's saved, I'll click run and then it'll run the simulation. Once the simulation's completed, it will print out or return a vec table. Amber. Okay, so let's run the simulations and look at the results. Oh, I don't think run vehicle. Oops, so I didn't have to make sure I did that right. So I did a typo there. So this should be an S. It should not have an S. I had an S there and I put one. So let's try it again. Let's see if it runs. Yep. It's going to create some folders to build the vehicle models within them. So now it's running. So in a few moments, we'll come back and take a look at the results. Okay, those simulations have finished, and I think I have a typo. Get results table. Let's see. Get result as vec table. I think, oh, I put another S. So that, again, okay. So if I did that, I could get it as an AVEC table. So it's an Amber vector table. So we could do a print it out nicely so you can see the name of the vehicle. We could see the cycle that it ran it on. And we could see where the results are saved. And if there were any errors. So the errors would appear here. So all of those simulation results were saved under this 2024-920 folder right here. And you can see run 1, 2, 3, 4. Those correspond to the runs that are in this table here. So we have the first vehicle on the UDDS cycle. And then we have the first vehicle on the highway cycle. And we have that first vehicle on the US06 cycle. So we have it in this AV table. You can do things with this table, like you can find, there's some methods here, you can match many and return as a subtable if you want to query it again. So you can match the vehicle property, and then you want to return, say, the value. Well, you want to match on, say, this vehicle. So you pass in key value pairs. So I want to say I want to match on vehicle, and I want to match wherever it's the vehicle, conventional midsize SI 5-speed automatic. And then I'll return a subtable with just those values in it. So that's a subtable that you can then iterate through if you wanted to. And you could also do the same thing if you wanted to get by cycle or process. So say you wanted to get all the vehicles with the FUDS.A cycle. So you put in the column cycle or process, then you put in the cycle name, you could get that. That also returns it as a subtable. You can pass in both if you'd want to narrow it down. So you can pass in multiple keys and narrow it down that way. That's what these AVEC tables are. And you could print it out. So if you just have this subtable, you can do a PRNT to print it out so it's readable. So those results also appear on this class. So if you do run vehicles and you do results, you can iterate through. Again, you could use either get the path, which is a cell array. So now this is a string that could be used, and you could load the results from each one of those using that string. That's a lowercase u, so you could plot the chassis speed. Back to this example here, there are some ways, once you get the vec table, there are some classes that make it a little bit easier in Amber to access the results. So you can do this results structure. So you do results, pxf, run, map, result, and then you pass it the table. And using this, what you can do is you can get individual results. It also loads some helper classes, such as a unit conversion and a dictionary, to get the nice display name versus the actual name that's used in the workspace. So we could do things like get the vehicle mass. So you could do results dot get result numeric formatted, and then you pass it in the parameter that you want to return. So it's loading the results. Let's see. Did I get results? Oh, maybe because this is result. Yeah. So now let's try it. What it'll do is it'll go through each result and load the result from each one. So that's a column of values. So we can do the same thing with, say, engine power. And you can obtain fuel economy, engine, plant, results dot fuel consumption dot total. And let's do a unit conversion on it. So we're converting it from liter per meter to mile per gallon. So this method can do the unit conversion on it. So those results are unit converted. Now, these values, they're just loaded from the mat file. So remember when I loaded the mat file into this variable A, those are just, structures on that mat file. So you can also obtain them just by loading each mat file and then, accessing each individual field in that structure. So it's a, engine.plant.scale.powermax desired is on that loaded result. So it's just loading the result behind the scene and then obtaining the value from each loaded result and doing the unit conversion on it. Perhaps one other thing, which would be maybe let's just quickly maybe let's just create a table. Oh, we want to make sure that we create these first. So I loop through each one. So what I'm doing is I'm just creating some labels for the rows and the columns. So then what we can do is we can see, make sure I run this. Does that give me a column vector? Yeah, okay. I get a column vector of vehicles and process labels. So then what I could do is I could do a results as, let's just use a MATLAB table here. So we'll just do the MATLAB table, and then we just copy in vehicle rows, process rows, and then let's put in engine power, and then we could put in vehicle mass, and then we could put in fuel economy, and then create a table that way. Oh, oh, maybe I didn't evaluate all those. Now let's try it. Okay, so then we get a nice MATLAB table. I could set the columns to something maybe a little bit more friendly. Could do that by setting the properties. Variable descriptions. Vehicle name. Processes. Engine power. Vehicle mass. Negative. Fuel economy. And then let's set the units. I don't think I did that right. Variable units. And the first two don't have any units because they're just labels. And oops, engine power is in watts. Vehicle mass is in kilograms. Fuel economy is miles per gallon because we did the unit conversion. And we could do, let's do a display on the results table. And then we could also write write results as table. Let's just write it to the current directory. And let's write it. We could pass in a file type to the MATLAB write function. Oops, write tables function. Because we're writing a MATLAB table out. So this is just the default table that's in MATLAB now. And let's just go to the runs folder, and we now just need to set these because we already had the table. And let's evaluate it. We get the mat file. So we get the mat file that's written out. So perhaps I not set the right variable names, not descriptions, my fault. This should be variable names. So let me redo that. There we go. Vehicle name, process, engine power, vehicle mass, fuel economy. So then let's delete this XLS file and then do the right table now. And now we can open this up. And in Excel, you can see we have vehicle name, process, engine power, vehicle mass, and fuel economy. Okay, that completes this demo.